Hey, here's the solutions for 2014 multiple choice. Starting with number one. This is, I don't know, my opinion, kind of a mean thing for them to start with. What you need to realize here first, there's probably all sorts of different integration techniques you might be considering looking at this, but this is just a monomial, just x squared on the bottom. So because it's only one thing on the bottom, we can divide through just using basic algebra. X cubed divided by x squared is x. 5 divided by x squared is 5x to the negative 2. And once you realize that, well, that's an easy problem now. Antiderivative of x is x squared over 2 plus antiderivative here, you got the 5, and then bump the exponent up by 1. Divide by the new exponent. That's just reverse power rule, and that's the same as this. So kind of mean there to make you realize that algebra on the very first one, but that's all there is to it. What's the slope of the tangent line to the graph of y equals natural log 2x? Well, let's see, the slope of the tangent line, so you need to find the derivative. Derivative of natural log of whatever is 1 over whatever, but it's not just an x there, so times the derivative of what's inside. 1 over 2x times 2, that's just 1 over x, so the derivative of that at x equals 4 is 1 over 4. I guess that's a chain rule question, right? Alright, here's a limit. If you have a limit question, unless it looks like the definition of the derivative, then you should expect to be doing L'Hopital's rule. We can try plugging in the 0. 0 over 1 minus the cosine of 0 is 1, so it's a 0 over 0. So L'Hopital's rule is definitely applicable. So that's the same as the limit as x approaches 0 of derivative of the top is 2x, and the bottom derivative of 1 is 0. Derivative of minus cosine is sine. And then we plug in the 0 here, and we get 0 over 0, so I got to go do L'Hopital again. And the derivative of the top is 2. Derivative of the bottom is cosine. Plug the 0 in now, and I get 2. Sorry about the sniffing, I'm just getting over a cold, but I'm feeling okay, just in case you were wondering. Might be a sneeze here and there, sorry about that. Alright, so how about the antiderivative of this? Well, just looking at the answers, you can see that these are all the factored things. Like, oh yeah, that's partial fractions. So let's see. In case you have a hard time factoring that, you don't have to look very far. Like there's the factors all over the place. Always want to look at the answers, just scan them before you start. So let's see, a over x minus 2 plus b over x minus 5. And then doing that little cross-multiplying, distributing kind of thing here. This is missing the x minus 5 factor, so ax minus 5a plus bx minus 2b. Well, that's all got to just be equal to 1. So the x part of that, the coefficients of that, there are no x's on the top, so that's got to be equal to 0. And then on the bottom, I've got minus 5a minus 2b is equal to 1. And I can multiply this top equation by 2 and add them together to get those to cancel out. So I get minus 3a equals 1. So a is equal to negative 1/3. And then b is going to be equal to, since a plus b is 0, b has to be the opposite of that. So I'm going to put the positive one first. So that's, this becomes 1/3 times 1 over x minus 5 minus 1/3 times 1 over x minus 2. So let's see, that's just a constant, and then the antiderivative of this is natural log x minus 5 minus 1/3, and then that's natural log x minus 2. There's nothing else funny going on with those antiderivatives because it's just a linear factor of x with a 1 there, right? If it was the antiderivative of 1 over 2x minus 5, well then a 1/2 would have to come out. But it's not. So I can factor out a 1/3, and then by logarithm rules, that's the same as x minus 5 minus turns into division, and that's the same as answer choice E. I cannot emphasize enough how important it is to look at a problem like this and scan the answers first, and that should definitely inspire you to factor and do this if you didn't remember. Figure above shows a graph of the function f. Which of the following statements are true? The limit of f of x as x approaches 2 from the negative side, so that's 2 approaching 2 from the negative side, is equal to f of 2. That's true because f of 2 is that point right there, so it is actually approaching that. F of 2 is -1, and it is approaching that, so that's true. The limit as x approaches 6 from the negative side, that's here, that's also approaching -1, is equal to the limit as x approaches 6 from the positive side. That's true. They're both approaching that same value at -1. Even though the point's in the wrong place, they're both approaching the same thing. Remember that the limit doesn't matter where the point is. They're approaching the same location. That's also true. And then third one, limit as x approaches 6 of f of x, that's -1 is equal to f of 6. F of 6 is -3, so that is not true. This limit does exist, but it's -1 because they're both approaching the same thing here. It just happens that point is sort of in the wrong place. So 1 and 2, what we're looking for there. Infinite series here has nth partial sum. So maybe we just need to remind ourselves what this means. The nth partial sum, S sub n, that means the sum of the first however many terms is equal to this. So what this means is if you add up the sum of the first, like say 2 terms, plug 2 into that, the sum of the first 2 terms is -1, the sum of the first 3 terms is 1, some of the first 4 terms is -1, and so on. So what does that mean? Well, for a series to have a sum, for an infinite series to have a sum, the partial sums have to be approaching something. So here, like these partial sums are not approaching something. They're bouncing back and forth. And that is no good. So let me just give you a quick example of what this is like. This is kind of like when we check endpoints, sometimes we end up with a series like this. And this is not the same as this, right? These are the partial sums. So let's look at this series and just make sure we understand what this means, this notation. What's the sum of the first 1 terms of this? Well, it's 1. The sum of the first 2 terms of this, that plus that is 0. The sum of the first 3 terms, 1 plus that, that would be 1. The sum of the first 4 terms is 0 again, and so on. So does this series have a sum? Well, on the one hand, you look at these and you say, well, it looks like it all adds up to 0, right? But we say that this sum does not exist, or that it diverges, actually would be a better, more appropriate vocabulary here, because the partial sums don't approach something. And if the partial sums aren't getting closer and closer to something, then that's no good. On the other hand, here let me give you another example real quick. Here's the a famous geometric series that converges to 1, right? And if you look at the first partial sum, it's 1/2. The second one would be 3/4. The third one is 7/8. You can get common denominators and check that if you want, but I promise you it is. The next one's 15/16. And if you look at the partial sums, those partial sums are approaching something. They're approaching 1. So the partial sums have to approach something for that sum to exist. All right, let's stop this here and we'll pick up with number 7 in the next video.